Okay, Assalamualaikum and very good morning. Okay, so for today's session, we finished the lecture 5. Okay, so which is the last part until for your final exam. For your midterm exam. And there's another 2 example will be discussed for today's session, and after that, we go for the revision session. Okay, so for this exercise, okay, so the problem is this one for the dam system. So when the boy riding a bicycle, so which is we can model as a single degree of freedoms dam system. Okay, and then all the variables for stiffness, weight, and damping were given. Okay, so which is in 100 newtons for the weight, and then 50 kilonewtons for the stiffness meter over meter, and then 100 newton seconds over meter for the damping coefficient. Okay, so there is step here. Okay, so which is can be considered as the step the step response in terms of displacement. So question asks to determine the displacement of the boy in vertical directions. Okay, so actually this bicycle is moved in the horizontal. Okay, and then after it reach at point A, and then because there is a difference attitude, okay, then you can create the vibrations in vertical directions. Okay, so we want to determines the displacement, so which is the x, x the function of t. Okay, and then we have to extract the information of initial conditions and completes all the information to find the response. Okay, so we assume that the basket and ball fall as a rigid body lah, so which is from the before it goes to the point A, and then after that have a step it fall 5 cm downward in downward directions. Okay, so based on these informations, we start measure at point A, so t equal to 0, so which is the initial displacement for this case we can consider as a 5 cm. Okay, so 5 cm, and then the initial velocity is equivalent to 0 lah. Okay, so because before it goes to downward directions, the velocity is in the vertical is 0. Don't be confused with this velocity. So this velocity is considered in the horizontal motion. So what we are interested about is in the vertical direction. So vertical direction is still 0. Okay, when t is equal to 0 lah. And after that is start motion. Okay, so to find the basically if you refer back for the equation, okay, so this is the response for the dam system. Okay, the first place you have to calculate the damping ratio, and then you can consider which equation you want to use. So if under dam, for example, this one, so to complete this response, you have calculate everything, the damping ratio, the omega n, omega d, okay, and at the same time you have to insert the information of initial condition. Okay, so back to this these questions. Okay, the first so you can calculate lah. Okay, so actually for the omega n is one of the most basic solution lah. So most of the solution require you to find the omega n lah. So that's why if you if you answer the in the exam, you blind, they know how to start, and then you can start with the omega n. It's very useful, and mostly there will be marks on it lah. Okay, so omega n here is a equivalence to k square root of k over m lah. Okay, so all the value is given, but m is only given in the unit of weight lah. Weight, so you have to convert to unit of mass. Okay, so that's why you have to divide by gravity lah, 9.81. Okay, and then we get the value for the natural frequency for that system. Okay, and then to get the response, you have to know the damping ratio. Okay, so damping ratio, you have to determine the C criticals. Okay, so C critical, just using the information, the equation lah, so put everything, then you get the value lah. Okay, and then for this case, you have at the first place you have to calculate the damping ratio. Okay, so damping ratio, this one is a C over C critical. Okay, so C is given, C critical you have already calculate, and then got 0.2476. So this one is less than 1. Okay, so this one is very important lah, because you want to know is either under damp, over damp, or critically damp. Okay, so for this case, this is less than 1, so meaning that is under damp. Okay, so under damp system. Okay, so which is you can refer the equation for under damp lah. Okay, and then under damp there is a the oscillation is based on its damp natural frequency omega d. Okay, so then you can proceed to calculate the omega d, then get the value lah, insert all the value, then got the solution. Okay, so this is the related formula lah for the under damp system. Okay, so you can just refer this formula and insert all the value that has been calculated lah. Okay, so put all the value. So actually this one you just you can solve this part lah. Okay, so actually your answer should be, if all the value is given, your answer should be in the function of t only. Okay, so this one also you have to insert the value for the zeta omega n. Okay, so just leave it as a t, because t, the value for x is depend on t lah. It's fluctuation, difference t, difference x. Okay, so this is the final solution lah. So but if you face this kind of question in final exam, make sure you complete the answer lah. So which is you have to press a calculator and find the final answer for this part, this part, this part, and also this part. Okay. Okay, any question? So this one actually the most important thing to, if a question asks you to find the vibration response for the free vibrations, which is this one, is there is no force applied. So you have to consider the initial condition. Okay, and then after that refer to the damping ratio. Okay, so if it's either under damp, over damp, or critically damp. Okay, after that you can just refer the equation lah. You can use equation. Okay, your midterm exam actually is closed book, but you are allowed to bring one page of formula lah as a reference. Okay, so you don't have to remember the formula. So you can just write down on the one page lah for your preparations. Okay, so now we go for the last example lah for lecture 5. Okay, a viscous dam system have a stiffness of 5,000 Newton of meter, which is a critical damping constant 0.2 Newton second over mm. So beware with the units. So make sure that you should convert into SI units later on. And then the load requirement is 2.0. If the system is given initial velocity of 1 meter over seconds, determines the maximum displacement of the system. So actually this question is almost same what we have discussed the yesterday session. Okay, so which is the question asked to find the maximum displacement. Okay, so which is for this case you have to know that the condition when the maximum displacement is happen. Okay. So for this case, should happens at the first peak lah, the first peak for the response. Okay, so you have to find the t at the first peak, and then after that solve for the solution, which is you have to actually you still have to find the relationship lah. You solve for the xt, and then you find the t and put the value into the equations. Okay. So basically this one is a most of the question is related with the under dam lah. Okay, so under dam, so if there is under dam response, so you want to find this value lah. So this value actually is happens when the angle is pi over 2. Okay, so to solve it, this is the given information lah. So if you know that the c is given in the unit of Newton second over mm lah. So you have to convert over meter, so which is equivalent to 200. Okay, and then the rest is given lah. Lot decrements given. Okay, so in the first place, you want to get the relationship lah. So which is this one. Okay, so you need the information of the omega n, you need the information of zeta, and then you need the information of omega d. Okay, so so everything is given, so you can calculate the cc. Okay, so in this one, so this one is getting given. Okay, and in this case, the mass is not given. Okay, so that's why can solve based on the c critical. Okay, so c critical is 2m omega n. Okay, or 2 square root km. Okay, so which is equivalent to 200 given in the questions. And then from this relationship, you can solve for m, which is m is equal to 2 kg. Okay, so once you secure the m value, then you can calculate the omega n. Okay, so apart from that, the information given is lot decrements. Okay, so lot decrements. Okay, so based on this equation for the lot decrements, and then okay, so actually if your question give the lot decrement, the amplitude ratio, that information is very useful to determines the damping. Okay, the amount of damping for that system lah. Okay, so for this case, given the lot decrements, and then just using the information for the lot decrements to get the zeta lah. Okay, so zeta is 0.33. Okay, and then from the zeta, and then we can extract the c lah. Okay, so c, the damping coefficient. Okay, so this one is solved lah. Okay, so which is for the c damping coefficient. Okay, and then based on the initial condition. So initial condition, the question stated that the initial velocity is equivalent to 1 meter over seconds, and then there is no information about initial displacement. So in that case, we just assume initial displacement is equal to 0 lah for this case. Okay, because there is no information given. Okay, unless it's given, then you can just input the value, the given value lah. Okay, so now we can simplify the st lah. So st actually based on this information lah. Okay, so this solution. Okay, but when the s not equal to 0, we can just eliminate this part lah. So that's why you can see that it's a bit simple. Okay, so we simplify the equation into this form. Okay. Okay, so now this is the response for that system lah under initial conditions. Okay, but the question asks to find the x maximum. So x maximum is happen when omega dt is equivalent to pi over 2 lah. So which is here. Okay, so this one omega d, omega dt. So sine 1 lah. So the maximum number sine 1. Okay, so which is pi over 2 lah. So which is the sine omega dt is equal to 1 lah for this case. Okay. So the omega d You can calculate based on the given information lah. So we have calculate the zeta, we have calculate the omega n, so it's not problem lah. Okay, and then from that, based on this relationship, we can determine the t value lah when it reach the maximum amplitude. Okay, so which is equivalent to pi over 2 omega d or 0.033 seconds. So then we just insert this value into this equation. Okay, when zeta is equal to 0.333. Okay, so actually you can put into this 0.033, or we just, for this case, just using equal to 1 because we know that when you put 0.033 is equivalent to pi lah. Okay, so 2 pi, pi over 2, so which is equivalent to 1. Okay, so just insert all the value, then you can get the maximum displacement. Okay, so that's the information required lah to find the maximum displacement. Okay, so which is you have to consider the angle when it which is refer to the first peak. Okay. Okay, any question?
No, Doctor.
Okay, so I think this is the last page for the lecture 5. Okay, so actually your midterm exam is covered up to this point lah. Okay, so I think we take break for 5 minutes. I want to set up for the revision session lah. Okay.
Okay, Doctor.
Okay.